It is time for us to combine everything we've learned. Groups, vibrations, even the univalence axiom. We are going to learn about the semi-direct product. Let's see how it works. Suppose we had the spaces A and B, each representing a group. Let F be a type family that maps A to the universe of pointed connected types with no higher dimensional holes. In other words, groups. We'll define F of base A as B, base B. We then say that the semi-direct product of the loop spaces of A base A and B base B is the loop space of the vibration of A with respect to F. But what on earth does that mean? Let's draw a picture. It follows from the functoriality of F that for every path P from base A to itself, we need a path APF of P from B base B to itself. But to construct a path between pointed types, we first need to construct a pointed equivalence between those types. We'll let phi of P be such an equivalence and define APF of P as being UA applied to phi of P. It follows that our pointed equivalence is a special kind of homomorphism that, given a path T from base B to itself, we have a path AP phi of P of T from base B to itself. We call it an automorphism. We thus have a group whose inhabitants are pairs of paths from base A to itself and from base B to itself. For any two such inhabitants, P, Q and R, S, we can compose them as P composed with R and Q composed with AP of phi P of S. For example, if we took the semi-direct product of Z2 and Z3, where AP phi of loop sends loop to loop squared, we get the group S3 of all the symmetries of a triangle, where a flip and a twist is not the same thing as a twist and a flip. We now know how to construct semi-direct products in homotopy type theory. Thanks for watching.